Welcome back to Learning Unit 8-3. Let's start with number 1. Sunshine Music Shop bought a stereo for $600 and marked it up 40% on selling price. Make note of that. To promote customer interest, Sunshine marked the stereo down 10% for 1 week. Since business was slow, Sunshine marked the stereo down an additional 5%. After a week, Sunshine marked the stereo up 2%. What's the new selling price of the stereo to the nearest cent? What's the markup percent based on the original selling price to the nearest 100%? So we have to figure out what that original selling price is going to be. So it's going to be selling price equals cost plus markup. Our cost is $600. Our markup that we want on selling price is 40%. So we've got the selling price equals 600 plus 0.40 S. We need to combine like terms. So we're going to, since we add, we're going to subtract 0.40 S from both sides, and we end up with 1S minus 0.40 S equals 0.60 S. So because we have 0.06 S that's multiplying, we have to divide to isolate the variable. So we divide both sides by 0.60, so we end up with S equals 1,000. So that is our selling price to start with. But then we have a 10% markdown. With the 10% markdown, we're actually saving 10%, but we're paying 90%. So we take 0.90 times 1,000, which equals $900. Then we have a second markdown of 5%. So again, we're saving that 5 cents on a dollar, but we're paying 95 cents on the dollar. So we take 0.95 times $900, that selling price that we created or calculated after the first markdown, and we get $855. Well, after that, we do an increase of 2%. So we add that 2% to the 100% base, and in decimal it's 1.02 times 855, and that equals $872.10. And that is our final selling price. So if we took 1,000 minus $872.10, it equals $127.90 in savings, divided by 1,000, which is the original selling price, shows us that we have 12.79% margin. Number 2, Alvin Rose owns a fruit and vegetable stand. He knows that he can't sell all his produce at full price. Some of the produce will be marked down and he'll have to throw some out. Alvin must put a high enough price on the produce to cover markdowns and rotted produce and still make his desired profit. Alvin bought 300 pounds of tomatoes at 14 cents per pound. He expects 5% to spoil and marks up tomatoes 60% on cost. What should we price per pound those tomatoes for Alvin? Well, if we look at the blueprint, we'll see the facts, and that is that we've got 300-pound tomatoes at 14 cents per pound. We have spoilage of 5% and a markup on cost of 60%. So we're solving for the price of tomatoes per pound, taking into account this perishable item. So we're going to calculate total cost. Total cost is going to be the 300 pounds of tomatoes times the 14 cents per pound, which leaves us with $42. We'll calculate total dollar markup. So our total selling price is going to be total cost plus total markup. Total cost, which we just calculated, was $42. Total markup on cost is going to be the 60% times the $42. So that's going to leave us total selling price of $67.20. That's what we need to make by selling all of the tomatoes we have available for sale. Well, we knew that there was going to be some spoilage, and that was 5%. So we look at 300 pounds times that 5%, and that shows we're going to lose 15 pounds. So instead of having 300 pounds, we're only going to have 300 minus 15 pounds equals 285 pounds available for sale. So to calculate the selling price, we take the $67.20 that he needs to make, divide by the 285 pounds available for sale, and we have a price per pound of 24 cents.